always good to come at the testing problem from a number of different perspectives. And so what Merrick did is he created what he called a catalog of test requirements based on his experience with things that tend to be buggy. Right? So this is kind of the original bug taxonomy-based approach to testing. It's probably the first documented instance that I can find of that. In this case, it's kind of refined because the bug taxonomy is generalized. So you're not looking for specific bugs, but you're looking for types of bugs, and it's generalized into test requirements. And in fact, this is an interesting parallel. If you read Merrick's book and then pick up, say, James Whitaker's book, How to Break Software, or some of the subsequent books that Whitaker wrote on the same How to Break Software Security and so forth, that series, you'll see that Whitaker's concept in many ways descends from Merrick's and is just a somewhat more formalized version of it, in the sense that there is a fundamental model underlying Whitaker's work of how bugs happened. But the idea that we can generalize from frequently observed bugs into things that we should test, and then we can cover those requirements, test requirements, with tests, then that's definitely very similar to Whitaker's idea. Now let me, before we look at the Fibonacci, let me go ahead and show you Whitaker's, or excuse me, Merrick's catalog. This is the test requirements catalog from Brian Merrick, and it is available out on his website. Not sure he sold that. It was on testing.com. It's somewhere else now. But if you were to take a look on the internet, Merrick's test requirements catalog, I'm pretty sure that you would find it, and you'd be able to see this thing. It's basically, there's a bunch of data-centric test types, as you can see here, simple data types, collections of data, pairs of data, and then it's got operations that apply to the data types. That's part 2, searching, streaming over sequences, changing contents of a collection. And so he then goes into a description of this, and we'll look at one example here. So for example, for a Boolean, you need to make sure that you've tested both the true and the false value, and if it's restricted to be 0 and 1 only, try to force it to be something else, in other words. And then different possible values that a variable can take on, and so forth. So this is a useful alternative way of looking at white box testing, is based on, as I said, where you're likely to find bugs. Let's go back to the presentation here for a moment. Now, what we're going to do is take a look at the application of Merrick's catalog to the Fibonacci program that we've been looking at here. So bear with me while I've got to switch applications. What I've got here is I've got the requirements, the test requirements that apply, and then the type of requirement it applies to. You'll see how this works as it goes through the you go through the requirements catalog, and then it generates the technique generates a set of tests, and this is the set of test IDs here. Here are the test cases themselves. And what I've also done in these set of tests that were generated, the 6 sets that were generated, I checked to see if this was something that would have been generated by the other techniques. So it wants us, the requirements catalog wants us to test -1, 0, and 1, and those are values that already would have been forced upon us by McCabe, or generated by McCabe's technique. And then it wants us to test the maximum value that can occur, and that's or can be input. Excuse me. That's 2 billion and change on a 32-bit processor. And we would have tested that also with the statement branch condition loop kind of code flow coverage anyway. But there are some things that McCabe says that we should definitely do that we wouldn't necessarily have had to do. For example, he says that you should select a typical value, which I said 10 would be a typical value, so it produces this Fibonacci series that you see here. Typical value in the input range. And then also try a value where the input and is going to be different than the return. Notice that we return n unless the input is less than 1, in which case we always just, or excuse me, less than 0, in which case we always return -1 as a code saying that we got a invalid value. So it's saying you want to check that happens. You want to test that reassignment of the code. So it does tend to generate some tests that you wouldn't otherwise necessarily have looked at, and so thus it is an interesting technique and potentially useful. Okay, so that is sort of a roundup of the common techniques. And here, this slide shows a recap of the test design approach with Merrick's tool. You review the requirements, design, code, and structures, compare the elements of this checklist or catalog, and then you accumulate what Merrick referred to as clues, which were the test requirements to be run, and then you create tests that cover those. And one thing interesting that Merrick said was try to use as much variety in your input data as possible, because you might stumble across a bug that is hiding in there and not amenable to discovery. So that's another good insight from Merrick, that the other code coverage techniques say, well, it doesn't matter what input values you use as long as they force particular code flows or data flows, in the case of data flow coverage. Merrick said, no, it really does. It does matter. You should try to have as much variety in your data as you possibly can. So we've looked at these different techniques, and we say, okay, well, the white box sounds like it could be useful, but how does this compare with other techniques that are out there? Well, basically, you've got static techniques like reviews and static analysis and so forth that involve testing without running, and those are going to identify bugs before, in some cases, before the bugs are built if you're doing a static review of a requirements or design specification. This is something that would typically involve, ideally, as many stakeholders as possible and happen during specification and development. And then there are a wide variety of tools available to do static analysis and support this. So it's a good idea to use static techniques, including code reviews, but also other things, prior to getting into coding. I mean, once you've created the code, then your opportunity to prevent bugs is gone. You're now going to have to just grind the bugs out. So as we've discussed, white box testing is testing how the system works, and the idea is to identify functions in the bugs or in the interfaces between, or identify bugs in the functions, or the interfaces between functions. This is typically done by programmers as part of, say, a unit component or integration test, and there are also plenty of tools to support this, though, again, I'd be curious if any of you run across a data flow coverage tool. And then we have, of course, the black box tests, which would be testing what the system does, looking for bugs in the results and the behavior of the system. And this is typically the domain of independent testers and often predominates at the higher levels of testing like integration system and acceptance. And as those of you who are testers know, there are plenty of tools to support this. Now, these techniques are complementary and can be can and should be used on every project, or just about every project, because they tend to find different kinds of bugs. They have different strengths. So by using a